Hello folks, welcome to your first lab. I'm your lab partner, all right? So you're gonna be like right next to me over here. And don't worry, I showered, clean, I smell good. All right, now, you can see the brand new computer that we have here. Hot off the press. No, it's a freaking dinosaur. But I can't get into my MCC lab, they won't let me. And they've locked up the computers, and I don't have a key. So I found this bad Larry right next door in the storage room, sitting on a shelf. Dusted it off, still has the software, and it's gonna do the job. Awesome, it does work. I've actually tested it, so it's all good. We've got the software still in this whole computer. We've got the gravity drop, acceleration due to gravity lab ready to go. I've actually got it set up for you now. What I'm gonna do is, well, actually, let me give you a quick up close and personal. All right, you will see right here, we have a ball. That is a steel ball. It is locked into position above a pad. That is the pad it's going to drop on. When I release the steel ball from that little windy thing, the steel ball falls onto the pad. Are you getting seasick yet? Oh, sorry. Sorry. All right, now, it's going to fall on the pad, and this bad Larry right here, this brand new computer, is going to time it. You can see here, it has a stopwatch function. I'm going to click record. When I click record, I hope you can see this. I don't know if it's in your view or not, but it zeroes that out. Let's see, are you seeing this? Are you seeing it? Yeah, you are. Okay, good. And then when I let go of this, it's going to record here the time. Let me demonstrate for you. All right, so we let this go, boom, and then bam. The time it takes for that ball to fall is recorded by our very heavy old stopwatch. That's essentially what we've got here is a stopwatch, an accurate stopwatch. If we were in lab, I would have you take a 10-minute quick, I'm putting you back here, all right, okay, stay with me. I'd have you do a quick 10-minute activity where you just take an object, like you take a steel ball, and then you take a stopwatch or your cell phone, and you would hold something from 1 meter and time it. Drop it, time it, and get a time. And from that, using one of the big three, and if you've watched the videos, which you should have by now, if you've watched the videos, you will know what I'm talking about with the big three, you would be able to calculate the acceleration due to gravity. Not very accurately though. You're gonna find that this, from 1 meter or even 2 meters, I have you go to 2 meters, is not very accurate. Well, I can have you do this at home. I suppose I could. Sure, try it at home, not for professionals only. Measure out something, 2 meters or 1 meter. You might not be able to get 2 meters in your house, but there are apartments. So measure something, just take 1 meter high, take an object, time it, drop it, use one of the big three, calculate you see what you get. Typically people will get anywhere from 12 to 18 meters per second squared. Now you know that the true value is 9.8 meters per second squared. You know that. So therefore you're way off. Why are you way off? Right there. Your timing is way off. And you can see when something falls, it doesn't take very long for it to do that. So just being off by a 1/10 of a second, a 20, or 2/2 of a second, you go, that's not much, is it? But it is when you're dropping something from 1 meter and something's gonna fall, it only takes 0.4 seconds. If you're off by 0.2 seconds, that's a 50% error. Huge, huge. So you are not accurate enough to time things when they fall. Unless they drop from a really high height, then you can be relatively accurate. Small errors won't matter then. Small errors would matter here. You're not gonna be able to accurately time something, so that's why we have our computer. Now, yeah, I know it's an old computer, but it works, okay? This is not gonna be a reason we have errors. This computer does work, it makes an accurate time. I know how long it takes something to fall 10 centimeters, which this is, and it does take 0.14 seconds. And you can do the math on that too and figure it out. All right, so what is this lab? What are we doing in this lab? What you're doing, what we're doing, partner, yeah, you and I, what we're doing is we're going to take the steel ball and we are going to drop it from the clamp, put it in the clampy thing, from the various heights. I'm going to increase the heights. This is approximately 1 meter, and I'm actually going to go to 1.5 meters because we are going to graph this data, and we're going to need 14, 15 points of data. So I'm going to go to 1.5 meters. Now you might be saying to yourself, Self, how are you going to get 1.5 meters? I mean, look at that. That's just 1 meter right there. So how are you going to get 1.5 meters? You're going to put books underneath it? You could do that. I'm not going to actually do that. I'm going to take this pad, put it on the floor, and then take this and just have it lean over the top, and then drop it onto the floor to get 1.5 meters worth of data. Now this is a lather, rinse, and repeat, a very repetitive lab, just getting doing the same thing over and over again through 15 times 15 pieces of data. So let me show you what I've got set up here. I've got this set up so I've measured it. So it's 0.1, can start at 10 centimeters. So 10 centimeters, so I'm gonna put this back in the clamp, put it back in there. And I'm going to measure. So what I do is I measure from the pad, because that's where it's going to hit. There's an electronic signal that's sent to the computer as soon as I release this. This is all electronic. It's physics 2. You'll learn about magnetism in physics 2, okay? Stay tuned. So you let this go, breaks the electrical circuit that tells the computer start timing, and when it hits the pad, that picks that up as an electric impulse, electric response, and it tells it to stop. So it's very accurate in terms of its timing. So now 10 centimeters is from the pad to the bottom of the ball. So I look at the bottom of the ball, get down to level. Okay, you don't want any parallax. Okay, you know what parallax is? All right, you've heard of a pair of pants, a pair of scissors, but not a parallax. Why would you want 2 lax? It's funny. Well, if you're sitting in a car seat, in the passenger seat, you look over to where the driver is and look on the dashboard and see the gas gauge. You might freak out and go, oh my God, we're on E, we're out of gas. And then the driver says, what you talking about, Willis? We have 1/4 of a tank. That's parallax, okay? So you make sure you're at eye level. And when I do that, I've got this, wrong side, at 10 centimeters. The bottom of the ball is at 10 centimeters. Now, I'm going to do this on my own. I know you be my lab partner, but you've had a rough day, so you're sitting back and recording data. Well, I'll do this. And it's not the easiest thing in the world. It would actually be helpful if you were here in person to move this up and get it to the next level, and perfectly with that bottom of the ball. It's a little rough, so there could be some error because of that. So I'm going to do this in 10 centimeter increments. Every 10 centimeters. So we started at 10, we got that time already. Well, I just touched it, so I screwed it up, but it was 0.14, so write that down, 0.14. You have the lab handout, go into Essential Course Documents, find lab number 1, acceleration due to gravity. Click Open. You can print it off, or you can just copy down the data page. You're going to need the data table. The data table is going to have distance and time. So we're recording distances and the time it takes for these things to fall, the steel ball to fall. I'm using a steel ball. It has very little air resistance. It's round, it's relatively heavy, it's relatively dense, so we're not going to get any air resistance from this height at all. If you're dropping off the Empire State Building, we might, but not from 1.5 meters. So no air resistance. And when we get the times, record the times for each height. And of course, the time should be going up as we go higher and higher. We want to be accurate, so I went out to the 100th place. I could go farther than that, but the truth is, you're going to end up graphing this data, and graphing out to the 100th place isn't going to make any difference. It's not going to help you any. So we went to the 10th place. All right, so you get the next one. What I'm going to do, I'll do this for you here. So it is a pain in the patoot, but I need to get this 20. So let's see, I'm going to estimate. And a little bit higher. Higher. All right, get to the eye level. And lock that bad Larry in. Okay, lock and load. So we've got that locked in. Pilot the Bombardier. You gotta have good Bombardier skills for this lab, especially at 1.5 meters. Bombardier, good. So we are going to now click on stop record. Not that you need to know this, but what it does is it zeroes out the timer and the stopwatch here. This very heavy stopwatch, accurate but heavy, is ready to go. So I release the hounds, and then boom, and we get 0.2 0.2 seconds for 20 centimeter drop, and you'll write that down, all right, in your data table. So we've got to do this 15 times. That's going to take a while. Do you think you're going to sit here and watch me do this 15 times? No, you're going to go bored. You're going to go watch some episodes of Seinfeld or play some Clash Royale or something while I'm doing this, because you're going to be bored. So I would say go do that. Now, so what I'm going to do at this point is I'm going to shut the video off. I'm going to finish getting you your data, and then I'll be back, and we have to go over what to do with the data. This lab itself is, in terms of what you have to do with the data, getting the data is not that difficult. And most of you, if you were in lab, would have it done in about 15 minutes. So getting the data is not hard. What to do with the data, that is. And in fact, what you do with the data might be the most challenging of all the labs that we do for the entire semester. So we start you off, boom, sink or swim, baby, sink or swim. All right, so we will go over what to do with the data. You are going to need graph paper for this, and I'll remind you of this again when I restart. You will need graph paper. I loaded graph paper in, but you are going to physically need graph paper because you are going to hand draw. I know, no, not on a computer, hand draw a graph. It's a skill that college is called College Board. They kind of dictate what colleges want from their students, and a skill, an old skill of actually hand drawing a graph is still important. College. So we are going to hand draw a graph. All right, but I'll go over that when this video is complete, when I get the data, and I'll be back. All right, like Arnold, I'll be back.